Hi to this quick guide on how to partition incoming shortwave radiation into its direct and diffuse parts, as well as on how to calculate incoming longwave radiation in case you do not have this measured, as both of these are required as inputs to Urban Tethys-Chloris. To run the radiation partitioning, there is a small code provided with the model. To run the radiation partitioning, we open the Run Radiation Partitioning file here. In this file, we first need to load the forcing data, which is not partitioned yet. We will need to assign date in MATLAB date and time format, air temperature, precipitation, relative humidity, and the total incoming shortwave radiation. This means the direct and the diffuse parts. We will also need to specify some location parameters, such as the difference between Greenwich Meridian Time, latitude, longitude, and the elevation of the station above sea level. The radiation partitioning performs some iterations to find the optimal integration time step. If you would like to have a visual output of this, you can put a 1 in the graph _ variable output. If you do not wish to get a visual output of this, you can put a 0. In case your meteorological input time series does not contain long-wave radiation yet, you can also calculate this easily in this code. For this, you just put the calculate long-wave radiation parameter to 1. If you do not wish to calculate long-wave radiation, just put this to 0. With this, you're now all set to perform the radiation partitioning and the calculation of long-wave radiation, and you can just start the code now. The result of the radiation partitioning, meaning the direct and diffuse shortwave radiation, as well as the longwave radiation, is combined with your original meteorological data set and is then saved under Meteo with the radiation partitioning mat. As an output to the radiation partitioning, you will also get two graphs. The first graph shows you the direct, the diffuse, and the total incoming shortwave radiation. This graph gives you a visual image on how the result of your radiation partitioning looks like. The second graph, which you get as an output, is the difference between the measured incoming shortwave radiation and the simulated radiation partitioned incoming shortwave radiation. As you can see in the first graph, there is a slight non-closure of this difference. This difference is caused by measured incoming shortwave radiation in the very early or the late evening hours. During these time periods, the code assumes that there is no incoming direct shortwave radiation, and hence we get a slight mismatch. To solve this small issue, we just add the incoming shortwave radiation, which we measured here in excess, to the diffuse shortwave radiation. With this, we get a good closure between measured incoming shortwave radiation and simulated incoming shortwave radiation. I would like to mention though that these differences should be small and they should only occur in the early morning or late evening hours. If this is not the case in your radiation partitioning, please check the assignment or check the code. With this, you're now all done with the radiation partitioning and the calculation of incoming long-wave radiation. You can start your UT&C simulation now.